Hello and welcome to this video. If you're in Math 082, this is Chapter 5.3, and if you're in Statistics, this is Chapter 3. The topic of these videos is organizing quantitative data. In my previous video, I demonstrated how to create a frequency table, and I also explained how to identify upper and lower class limits, as well as the class width of a frequency table. In this video, we're going to learn how to create a stem and leaf plot. It's important to understand that there are many different tools to organize quantitative data, and depending on the nature of your the nature of your data, one tool might be superior to another one. For example, if you think about building a house, a hammer and a screwdriver have very different tools. If you're trying to use a nail and put a nail into a wall, you would use a hammer. If you're trying to put in a screwdriver or something like that, put in a screw, then you would use a screwdriver. So likewise, stem and leaf plots have some strengths and weaknesses, as well as dot plots and histograms and so forth. So you're going to learn all of these tools, and then hopefully, as you go through and have this set of tools, you'll be able to make an educated and informed decision about which tool is the best tool to use depending on the nature of your data set. So let's get started here. So this first slide discusses frequency distribution. So generally speaking, a frequency distribution shows how data is partitioned among several categories or classes or bins. So all of these ways of organizing categorical data, not all of them, but a lot of them are predicated on putting data into bins. Also, we need to understand that our sample size means the total number of data points shown. So let's get started with a stem and leaf plot. This is also referred to as a stem plot if you're using StatCrunch. I believe that StatCrunch calls it a stem plot, and I believe that it's under the graphing utilities in StatCrunch. So notice if you're in my stats course, all of this can be done using technology rather than by hand. I go through it and explain how to do it by hand just so that you have an understanding of these tools. Okay, so what does a stem plot do? A stem plot represents quantitative data by separating each values into two parts, which is the stem, I'll draw you a stem right here, and then the leaf. Isn't that cute? All right, so that's what we're going to look at. And again, it can be created by hand or using technology. So here is our data set. I used the same data set in a previous video. So we're going to imagine that we took a sample size of 10 people with whom we're friends on Facebook. All right, so let's get started. How can I make these into stems and leaves? Well, what we're going to do is we're going to take each number, for example 12, and we're going to cut it into two parts. And this upper part, if you remember from elementary school, we call this the tens place, and we call this the ones place. So the higher number, the tens place, is going to become our stem, and just for fun, let's use brown for stem, like a branch. And then the ones place, we're going to consider that our leaf. Now, all of these numbers that we're working with have two digits, right? 12 is 1 and 2, 17 is 1 and 7, and so forth. The only problem here, as you might notice, is 9. So poor little 9, he has a leaf, but he doesn't really have any stem. So how can we fix that for him? Well, let's see. Here's a leaf, right? But it looks like he's missing a stem. So I kind of need a placeholder for him to give him a stem, and that placeholder is going to be 0. So let's start filling out our stem and leaf plot. So we start with the lowest stem, if you will, and hopefully you can see that the lowest stem is 0. As we move on, the next stem is 1. we need to keep going even if the stem value is not represented in our data set. And you'll see why in a minute. So we're going to have 0, 1, 2, 3, 4, and 5. Now let's go through our data set and use tally marks to, or not tally marks, I'm sorry. Well, we'll be crossing off our data as we go and then filling in the leaf portion. So I'll keep using green just for fun. So the first leaf that we have is 9. So the way I would read this is that there is one data point on stem 0, and that data point is 9. Then we have 12. So I'm going to rate a 2 here. So again, the 1 in the stem part and the 2 in the leaf part gets combined and interpreted as the number 12. Then I have 17. Well, that also attaches to the stem of 1, so I use a comma to separate values over here. Now, just so you understand, I believe most software programs do not use commas. I like to, just as a visual barrier or representation, but again, the software programs will not do that. Alright, so then we have an 8, and we have a 9. Now we have 20, so we're moving on to our third stem. And then we have 21, and we have 25. Alright, now we don't have any leaves growing on the 3 stem, and we don't have any leaves growing on the 3rd stem. Does that mean we should write 0 here? No, because then we would be led to think that we have a friend on Facebook who is 30 years old, and we don't have that in this sample. So we have to keep going to 40. So we're going to have a 9 here at 40, and we have a 2 here at 52. And I think I misspoke earlier, I apologize. I think that I said we don't have any leaves at 40, and that's not true. So please forgive me. All right. So the reason I like stem and leaf plots so much is that just by creating one, you almost have a sort of bar graph, if you will. And you can see almost where is the highest frequency and where is the lowest frequency in your distribution. So that's one of the advantages of using a stem and leaf plot. So just looking at this, can you guys see where are the majority of our Facebook friends grouped? Well, you can see that right here in this area. And we'll get to this in a later video, but our peaks on histograms, when we get to histograms, are called modes. So that's how you create a stem and leaf plot.